Hello again, and once more, welcome back to the cellar. In this episode, I am going to be taking the breadboard design controller that is currently sitting on board E and starting to try and make a hopefully more reliable prototype on stripboard. I've got a little bit of the way, and today we're going to be finishing this off and hopefully show the system powered up before all the coding goes in. This is Leopard Street. Now we're back at the desk. What we have here is the board controller for board E. It's going to be a little bit of a prototype for controlling elsewhere. ESP32 microcontroller, a little built-in screen which saves me from having to program things. It's 128 by 64 pixels, although here I'm just using it as a text screen for 8 lines and 20 characters, I think it is. Lift this off, and there's a few wires underneath it. Connect some of the pins to this socket, which if I turn out, you can read the labelling on it. This is LED. This goes off to a TLC 5947 LED, pulse width modulation controller, which is driving LEDs. Shade that slightly, you'll be able to see the... Sorry about the glare, I just need to try and get some light on here. And this socket here, labelled PCF, goes over to a PCF 8575 16-bit I2C I/O controller, which is that. As you can see, I've connected, instead of the usual sort of header pins, done a little bit of soldering and put in some connectors. So this PCF board connect like that. Little jumper wire. There's a similar one for the lighting controller. Just unplug that, which in turn has different number of wires. It's actually a 5 pin at this end, it's actually a 6 pin at the other end, because that one's got a 12 volt line added into it. And over here we've got the power inputs, plus 5 volts ground, same thing on the end, just with a plug and play sort of screw terminal that has been forced in. Now, what I need to do today, I'm going to be adding the servo controller. So just unscrew some of these. And I'm going to need to prepare that first. If we look on the back, you can see the sort of the arrangement. I wouldn't use the word designed with regard to this. This has basically been put together. So, hand out of the way. This has been put together on the fly. Hopefully, as you can also notice, I've now got slightly better audio down here. I've got a second microphone down at the desk in the cellar, as well as this little camera. Slightly awkward to show this powered up currently, because the lead it needs to power it up with isn't long enough to get in front of where the camera is. I think I've got another one somewhere. I'll have to have a look and see if I can find it. But that's the board, and today I'm going to be adding this. So, open this. This is a PCA 9685 pulse width modulation board. This is a clone of an Adafruit board. It says on the back, as you can see, works on 3 volt to 5 volt logic. The V plus pin, it's got actually 2 voltage input pins on this, which it says is... Yeah, it says V plus is 6 volt max. That's actually incorrect. It'll take quite a bit more than that. 6 pin input. Again, I'm only going to be using 5 of them. The V plus pin actually comes up to here. This is purely power. All that does is connect to the, I think it's the red terminal rail down here, V plus, yeah. That's power out to the servos, so 5 volts on that. That'll feed across. Black is ground, which comes out to here as well. I think it does tell you which way round is which somewhere. Yes, V plus, so that's the 5 volt side. This means this can be connected up to a power system. You also have VCC, which is the logic power level for this, which again is 5 volt to... I think it'll go down to 3. That's what it says on the back. So yeah, this will be fine to feed with the 3.3 volt logic from the controller. Need to make 2 slight modifications to this. I need to remove the output enable resistor, which I believe is this one up here. I'll just need to check on that. And this connector needs to come off because I need to put in one of my these little solder connectors, and I'll make up a pin for it, and then I will do similar on the circuit board. So first thing to do is remove that, which I shall warm the soldering iron up. Ooh, do apologise. Caught on the wire. As you can see, I'm very high tech here. I've got a little dot I can use. So I just need to move the light around a bit so I can see what I'm doing as well, hopefully without getting too much in the way. Now these come pre-soldered. If they didn't, I wouldn't have connected it. And the way to remove them is to realise the plastic is not actually connected in any way, shape or form to the metal. It's just a friction fit. So that can be lifted up. And once it's lifted up, finger out of the way again, can be cut. I cut into each of these. This means these can then be removed a little bit more easily. And removing them is, or should be, a relatively straightforward matter once I can get the soldering iron to it, preferably without knocking everything else off the desk. Is basically a case of heating them up one at a time and pushing them out. And some will come out more easily than others. There are better techniques for doing this sort of thing, but this is one of the cases I really wish these boards actually came with this not fitted. There's a lot of these little modules you get on the likes of eBay. This sort of thing's not actually installed properly, and then you can solder them onto your heart's content. So all you need to do is grab that. Maybe grab it from a little bit further up and heat the bottom. Now the pin's largely through. So I have to forgive me, I'm faffing around left-handed here with the cutters. This next video sequence is a little bit different. For whatever reason, the audio got decidedly out of sync here, so I'm going to be redoing this one. So what we need now is the board. Over to plan B, I couldn't get the solder out of the holes on that end, so what I'm going to do is solder the connector onto the other end. The pin's common all the way through, so you can daisy chain the boards. So this will work fine. It just means the board's the other way round. So I'm going to get on with that and fast forward that, and I'll be back shortly. These boards are actually quite versatile. These are I to C devices, so it's basically 2 pins, power and ground. The 5th pin is an output enable pin, so you can basically switch all the LEDs on, the servos on and off with a single line, which is quite useful. The I to C devices, it's got a 6-bit address, which are these bits across the top here. So you can actually daisy chain up to 64 of these. You get a default address, and each time you bridge one of these pins, you're creating another address. 64 of these each with 16 LEDs. If you've got the power to drive that many servos, good luck to you. And there's just a few other little bits and pieces on here that assist with making this run. And obviously you've got the connector that goes down to the bottom bits, down to the power, and that's the board pretty much configured. So what I now need to do is work out how we're actually going to connect this onto the board itself. Now what I want to do ideally is put the connector in line with the other two, just for aesthetic reasons. However, in practice I'm actually going to bring it down a little bit because I want a little bit more space for running some of the wires. The pins, really, it's an I2C device. The PCF board is an I2C device. It would be really lovely if these things would just plug into the same sort of sockets. However, third law of SOD is in effect, and the pin wiring is different between the two. So what I can't do is just put it down below. What I'm actually going to do is stick another 5-pin connector on here, which is this little one here out of the box. As you can see, I've got quite a few of these. And this is going to go on, and somewhere in the middle, yeah, I'm just going to take the microcontroller out. Just avoids damaging it, really. It also means I can see the wires inside. So instead, this is going to go, instead of going up here, which is where it would look quite nice, it's going to get moved down a bit. I just want a bit more space. I'm going to have to cut the tracks between the connector and the microcontroller anyway, because I don't want it connecting to the 5 pins directly above it. So what I need to do first off is solder that on. I'm then going to cut the tracks. Now, soldering, model railway soldering, it's a skill worth picking up, and basically if you can solder to wires to track, you can do stuff like this. These copper-clad strip boards are very, very simple to solder to. This one's fairly clean, even if they're not. You can just a little bit of flux and you're well away. The copper conducts the heat really nicely, takes the solder really nicely. Here I'm using quite a large tip on the soldering iron. You can use smaller, finer tips if you're not quite as confident with messing around with this. I've been doing this for a fair few years, as you'll see by the state of the bodges. Someone who's not been doing this as long takes a lot more care. So that gets the connector in there, and yeah, now I need to cut the tracks, which is a case of a little handheld drill bit. And what you need to do is cut those 5 tracks and make sure they're not cut in line. And here we've got a little bit of card, which is going to show roughly what I'm actually trying to do here. So that's what I've got for the LED controller. This is going to be the servo controller. So on the board, which is the control board, is on the left, the device is on the right. So the device has 6 pins, the board has 5. And essentially I'm just going to not connect one of them, and it's not that one. I'll remark that in a minute, because the board, I should say, that was originally would have been the non-connected one. However, because I've rotated the board round through 180 degrees, it's the other way up now. Doesn't really matter. I'll be wiring this up specifically for this orientation. What this means is if I decide I'm going to take this further onto a printed circuit board, which I probably will be, this is just something that will need to be sorted out to work out which way around I'm doing it. This is something that's well worth doing. You can get yourself a little bit of paper, make a note of what the pens are, and you can just double check exactly what you're going to do here. So here the V plus line is the one I don't want to do. That's the power line. I do have a separate connector which will be going into this here. I mean, this will be fixed to a little printed circuit, a little 3D printed bit, and it'll be dealt with that way. So that's what I need. I'm going to have a 5-pin connector. What I'm now going to do is solder these wires on. I'm not going to make you watch this all in real time. It doesn't take particularly long, but it's not that interesting. So I will carry on with that, and I'll be back shortly when there's something a little bit more important to note. And that's all the wires connected. You can see there's a black and red power wire. There's two little yellow wires which are handling the signal. The next bit that's needed is to replace the pull-down resistor that was on the board, which I removed, with a pull-up resistor, which will go on here, and that's what I'm going to use this for. It's a little 10k ohm resistor. So you've got a black for a brown wire for a 1, a black for a 0, and a orange for 3 zeros, so 10,000 ohm, 10k resistor. Normal sort of thing you use for pull-ups. This needs to go between the output enable pin, which is the unsoldered pin there, and the 3.3 volt positive supply to act as a pull-up on this. So unless I tell the microcontroller to turn this thing on, by default this will mean all the servos are off. So that just goes into a hole there, and that will then be soldered on the other side. And this will hopefully give me a little bit more control. This will mean I can configure servos without them actually moving, which is quite useful. Slightly sped up sequence here. This is where I'm soldering this resistor in, and what I now need to do is connect that output enable pin to the microcontroller. There's a lot of faffing. It ends up connected to the pin that's actually already marked on the board, the circuit board at the top, that little black mark by my finger there. While I try and work out, can I put this onto a nearer pin? Basically, the pins that are nearer are either being used or are ones you don't want to use in this way. I looked at using pin 15. If you use pin 15 and you connect a resistor to it, to one of the supplies, you can stop the thing switching itself on, which is slightly annoying. So in the end, I just went around for 33, which is the one I've used previously. Okay, now this is lined up. The next bit I need to do is make a connector to plug them together. There is a deliberate mistake at this point. Yeah, I correct that later when I realise it doesn't actually fit, but there we go. So to start with, I'm going to make myself up a little 5-pin lead which will go between the servo board and the other board. Won't have the 6th pin connected because that goes in via those little green screw terminals at the bottom. If you've not seen one of these before, this is a JST, I think this is PH, might be XH. I can never remember the names of these things. Basically, it's a 2.54mm pitch connector, which will work nicely with stripboard. And they come as little plastic housings and a collection of pins, and you then stick yourselves together. I'll show crimping one of these. I'm not going to show crimping them all because obviously it gets quite repetitive. You need the correct tool to do this with. If you go on eBay, you will find any number of these connector sets that come with all manner of crimping tools that don't work. The one you need some of these bits of wire. Now, as I'm using this Arduino wire here, I'm just going to cut the ends off this. Get this to length. I've found I can't crimp these things while they're still ribbon cables. They get in the way, and it's just awkward. You sort of need a machine to do this. So, and they are expensive. So here, just a case of before I strip the wires apart, cut them to the appropriate length, so they're all more or less the same length, and then it's going to be a case of stripping the ends off and sticking them into the crimping tool. Yeah, if you're going to be doing any of this sort of work, playing with these wires and the crimps, it's worth doing. You can just solder all this sort of stuff. If you make a mistake, it's awkward. Model railway boards tend things underneath. Here's the crimp you need. So what you do is you trim a little bit off the end, and however much you think you can trim in off, you're probably trimming off too much. Practice is well worth it. Using these things basically means you can do all the soldering away from the layout, which means when you've got one of these boards fitted underneath something, all you're really doing is making wiring harnesses and plugging them in. So here we get the tiny little connector, the crimp tool here. So what we do is we put it in the end and just squeeze the pins slightly. The machines that do this can cope with them being open, the hand crimps can't. So that has got two stages to it. There's a wider stage which grips the insulation, and there's a narrower stage which grips the plastic, and that goes in there. There's a little step, you can just about see it, and it has to sit up against that. It took me a while to work this one out. I'll try and do a clearer video on how to actually use these things, because these connectors are brilliant when it comes to this sort of thing. You then put the wire in and you squeeze, and when it comes out you have a crimped connector, and that's it. The bit near the wire, it grips onto the insulation, and then there's another bit that grips onto the inside of it, and it's just a little push fit into the housing. So that's that. I'm now going to speed up while I do the rest of those, and I'll be back in a minute. And with that, the cable's done. I will get better at making sure this sort of stuff's on camera. Now what we can do here, this can now be plugged in. I need to put the microcontroller back in. Before I power this up, I want to put it back on its little 3D printed base. This will eventually allow me to connect this to the layout nicely so it can on the folding flaps out of the way. While it's on the desk, it just stops any stray bits of metal getting onto the copper on the back of the board and shorting things out. And I don't want to let the magic smoke out of anything, because if you do that, it all stops working. As you can see, this isn't square. The board I'm actually using was printed to hold the DTC8 block controller boards, which are slightly squarer and slightly wider than this. So we now put the ESP32 back in. As you see, these header pins are nice. This one works quite nicely because there's enough pins there, it's quite high friction. So this now needs to be set up. So we can plug the various ancillary boards in. As noted on screen earlier, I can't plug the LED board in because it doesn't work. So this goes in. The thing powers up, and as you can see on screen, we've got the system working. The blue flashing light is a heartbeat indicator. We have on there, we've got the fact that this is for board E. We're connected on Wi-Fi. We have a Wi-Fi signal strength, which updates every time the heartbeat flickers. An IP address, and then below that 6 rows of data, one of which covers the turnouts, one of which covers the relays, 2 of which cover the LEDs, and 1 of which covers the block detection. Now at the moment, the only parts of this that work are the LED outputs and the block detection. So yeah, I can plug the servo board in. At the moment, all it'll do is its little power light will come on. However, what we can do is I can take the little PCF board, I can plug that in, and I can show you that working and that responding on the bottom. So what we do is we plug it in, which is this here. Now this wire is not brilliant for working on the desk, and the board will keep trying to slide around. This just plugs into the other bit, and again this sort of highlights the point. Once this is on a layout, there's no soldering. If I need to unplug this little sensor board, it's just unplug it. Don't need to cut cables, don't need to mess around with screw terminals in a not particularly well lit area. And there we go. So what I need to do now is, see, we've got this here, is plug this in, and there is a wire. Now these are active, let's get this one right here, these are active low sensors. So these pins are normally at a higher voltage. The board doesn't read it because nothing's changed, so it's just seeing a standard input. So if I plug that onto there and I touch that to ground, you'll see that bottom row change. It goes straight to zeros. It's to say all of them are nothing except for the one at the end, which has been grounded. So that is now showing there is something in that track block. So that maps to that, and if I change the wire around here to one of the others, this goes here. Now this has been set up. I've subsequently made a lead. I've not shown it on here. It's a different one connecting. So I can plug straight into one of the DTC8 boards. What you can't see on here is that is feeding back to the Mosquito server over 8 sensor channels, all of which are reported also into JMRI, which I don't have running here at the moment because the layout's not powered up, but it can see those as block detection sensors. Now this is where the problem came with the servo board. I've made a 5-pin connector at either end. Now the servo board, if you note, I soldered a 6-pin socket to. I probably should have just soldered a 5-pin socket to it because I really don't want that V+ pin exposed, but never mind. Lesson for the future. So here I just had to go in and remake one of these. Just basically take the wires out of the connector, which is extremely simple to do, and plug them back into a 5-pin connector, and then that goes back in. So with that fixed, we can now plug that back in. And as I said, all this is actually going to do is put the power light on the board on, so our little red LED comes on. In theory, the microcontroller can now communicate with it. In practice, the software isn't set up to do that, so I need to work more on that. And I'll probably do another video on how the software on this board works anyway. It's not particularly clever, but I like it. So now what we can do is I'm going to fire up well, firstly I attempt to fire up JMRI, and then that doesn't work, and I'm going to power up MQTT Explorer. Because you see those the LED rows, there are 3 zeros. This is controlling 3 LEDs. The MQTT system knows about 3 LEDs, but this board can actually handle up to 24. At the moment only 3 are configured, and it's told them to be off. The others are off because it's not been told to turn them on, but there's no instruction gone through. But what I can do, I can play around in MQTT Explorer, I can turn LED on, I can turn LED off, and those 3 zeros will gradually change into 1s and back again. And if this was actually connected to the layout, and I have had this little board connected to the layout, this would turn the lights in the signal box on and off. Once this is all fully back up and running, I will do a little video demonstrating that. But that's what this next little sequence shows here, is just these numbers changing. So see, it's fairly straightforward to do. As we've seen before, the idea of this layout is there are not a load of wires going between the boards. I've only really got the power bus wires, and this uses Wi-Fi, and this is how it communicates. All the little blue status lines there, they all represent information that's either coming in or going out, and so far it works. I'm quite surprised it works, but it seems to be working quite nicely. I've got to get this one finished off. I need to get it properly tested. I need to get the software fully updated, and then it's going to be tested for a while just to make sure this thing is stable. I was having problems with the domestic Wi-Fi. I've recently installed a signal booster, which seems to be working. These boards sometimes didn't connect particularly quickly. They now connect more or less immediately, and hopefully that'll work nicely when we're in place. You can see there's the first digit 1 coming on. That'll go off again shortly, and I think I've set up one of the other ones. But yeah, and that's just about it for this video. Bit of a longer one, bit of a more involved one on the some of the electronics behind this. I will say I will do another video where I go into the software. I will get the servo controls working first, and yeah, that's just about it for this week. So thanks everybody for watching. As usual, comments, likes, subscriptions, whatever, all welcome. Hopefully the sound is now better in the cellar, and I will try to work out why on earth the synchronization of the sound didn't match the video and what I can do about that for the next one. But yeah, thanks very much for watching. I will see you all next time.